Hey, welcome. You ever look at your phone and wonder how that metal frame is so perfectly stuck to the glass screen? Or how a super lightweight carbon fiber car part gets bonded to a metal chassis? It looks simple, but trust me, it's one of the biggest challenges in all of engineering. So today, let's dive into the hidden science of sticking very different things together. It's a question that sounds so basic, right? You've got two things, you've got some glue, why doesn't it just work? Well, that simple little puzzle is what sends top engineers and chemists at the world's biggest companies back to the drawing board day in and day out. And that right there is the heart of the problem. You know, on a microscopic level, some materials are just fundamentally incompatible. It's like they actively resist forming a bond, kind of like trying to mix oil and water. But the reasons they resist, that's where things get really interesting. Now, this isn't just some small inconvenience, it is a critical hurdle. In our modern world, we're always trying to join different materials to make our products lighter, stronger, and more efficient. And figuring out how to solve this unsticky problem, that's where the real innovation is happening. And this list of problem materials? It's basically everything around us. We're talking about the famously slippery coating on a pan, like Teflon, strong but fussy metals, like aluminum, and then you have advanced stuff, like carbon fiber, not to mention all the different plastics, glass, and composites out there. Each one of these presents its own unique challenge when you try to get something to stick to it for good. Okay, so to really get a handle on the challenge, we have to meet the villains of our story, these invisible forces that are always trying to pull our bonds apart. These are the enemies of adhesion, and believe me, they never quit. All right, the number one enemy is something called the coefficient of thermal expansion, or CTE for short. The easiest way to picture this is to think about the gaps you see in a concrete sidewalk, right? They're put there on purpose, so the concrete has room to expand in the summer heat without cracking. Well, pretty much every material does that. It expands and contracts with temperature. But here's the kicker. They all do it at wildly different rates. And that one single issue is the make or break factor for everything from a satellite in space to the circuit board inside your coffee maker. And this is where a constant tug of war starts. Take a look at this comparison. When things heat up, a plastic like epoxy, which has a very high expansion rate, wants to get a lot bigger than the aluminum it's bonded to. They are literally trying to tear each other apart from the inside out. So let's just walk through the life and death of a mismatched bond. It all starts out fine. You bond the materials at a nice, stable room temperature. But then, the temperature changes. The product sits in a hot car or gets left out in the cold. Because of that CTE mismatch, the two materials start pulling against each other. This creates an incredible amount of stress right at that tiny bond line. And eventually, pop, something has to give. The bond cracks, and you've got a total failure. And CTE isn't fighting alone. Oh no. You've also got to worry about things like thermal shock. That's a really sudden temperature change, plus humidity, all sorts of environmental stress, and even UV light from the sun, all of which can slowly eat away at an adhesive over time. It's truly a multi-front war. But don't worry, there is a hero in this story, the Adhesive Formulator. These folks don't just find a random glue, they actually design an entire chemical system to fight back against all those enemies. So let's open up their chemical toolkit and see what they've got. And this really gets to the core of the modern approach. We're way past the old days of just trying different glues to see what sticks. Today, it's all strategic. It's about understanding the deep-down chemistry and designing a solution from the molecule up. This means they're using a whole arsenal of tricks. For instance, they figure out how to make the adhesive wet the surface better. Think of it like making sure water spreads out evenly on a plate instead of beating up. They build in these tiny flexible components that act like microscopic shock absorbers to handle that thermal expansion stress. They even use special primers, almost like a base coat of paint, to get the surfaces ready to form a super strong bond. And when formulators master these strategies, it's not just some academic exercise. According to industry experts, this is what gives them true, real-world bonding expertise. It's the ability to confidently look at two different materials and say, yep, I know how to make those stick together forever. But you know what? Finding that perfect chemical formula in a beaker is really only half the battle. The biggest challenge is often taking that success and making it work in the real world on a massive scale. And this is a huge deal. A process that works perfectly for one single prototype in the lab has to work just as perfectly for millions of units rolling off a fast-moving assembly line. Making that leap from the lab to the factory floor, that's where so many brilliant ideas, well, they just fall apart.
And the stakes here could not be higher. We are talking about industries where failure is simply not an option. In the automotive world, in aerospace, a failed bond could be absolutely catastrophic. In electronics and EV batteries, the performance and the entire lifespan of the product depend on these connections holding up. This science is the invisible backbone holding it all together.
And just to give you a sense of the scale here, we're talking about over 100,000 professionals from thousands of companies all over the world who rely on mastering these techniques. This isn't some niche corner of science. It's a massive, critical field that makes so much of our modern technology possible.
So when you put it all together, you start to realize this isn't really just about glue. It's about a super sophisticated science that quietly and reliably holds our world together, from the tiniest little chip in your computer to the wing of the largest airplane. So I think the real takeaway here is that behind every sleek, seamless product we love, there's a huge amount of hidden science at work. This art of joining totally different materials together, it's truly one of the great unsung heroes of modern technology. So, the next time you pick up your smartphone, a device made of glass, metal, and plastic all joined together perfectly, just take a second to think about it. What invisible, high-tech bonds are you actually holding in your hand? And what other parts of your world are held together by this amazing science? Thanks for joining me.